Okay, good morning. From out of Leuven, the center of the world these days when it comes to organizing webinars on cybersecurity, we welcome you and we are broadcasting live this morning, June the 30th. It's a number of months that we have started these webinars, quite a number of them, the 11th already today. Here in Belgium, the schools are finalizing the last day today. I think the children that went back home for almost 3 months and then were allowed to go back into school for less than 1 month will find it very useful to finalize their time at school this year in any case, with some limited interactions and luckily also some interesting results. So thanks in any case for joining again this webinar. We will be talking today again about cybersecurity challenges and developments, and today they will be about Internet of Things. Also thanks to one of our members today is that Trend Micro, and we have Udo Schneider with us today to talk a little bit about this. Before we do so, let me introduce you a little bit the topic as we used to. So we'll talk about IoT because IoT is getting more and more important, and definitely also IoT within the context of cybersecurity is very relevant, highly relevant. A number of years ago, the projections for IoT devices were going into the trillions of devices by 2020. Now that we have reached 2020, the promise is still there. We have not yet reached 4 billion or even trillion devices. But there's quite a number of devices out there in any case. So the business that we still see in that IoT space is quite broad. Most of the applications that we see, and I'll have some examples of this, is in factory deployments, where IoT is actually being implemented as we speak on a day-to-day basis. And we talk about really thousands of devices, of sensors, of actuators on a day-to-day basis. But also beyond the homes, there's other environments where IoT are being implemented, and also in a very wide range of industries. In this case, for instance, also banking, insurance. So any type of enterprise today will definitely see some form of IoT becoming integrated within their networks, being it video surveillance devices, being it basically smoke detectors or fire detectors. Everything like these things today have some form of an internet connection, and that's the way that we also see the world evolving quite rapidly. In 2019, the number of devices being implemented in factories has actually gone beyond the ones that have been deployed in consumer IoT. And so if we take a look into what that IoT space really looks like, then it's already quite an extensive group of things that are being developed and that are being deployed. So we see many different sectors, many different applications, many different functionalities. So that whole space is just expanding as we speak and as we see it moving along. So when we focus ourselves, we try to focus a little bit more towards industrial IoT, especially because that's the world that we know better. We operate an activity called 3IF, where this is highly relevant and where we do install IoT devices in factories and have to come up with solutions also in relation to cybersecurity for those. There is some overlap between what's happening in the world of IoT at home, but specifically in the domain of industrial internet, IoT have a couple of other types of requirements, I would say. And while we see that there's this migration happening between IT and OT, especially in the domain of industrial IoT, again, also in industrial IoT, those devices require much more than in the home, things like resilience and reliability, safety, further and beyond the concerns that we would have in the homes, like privacy. The IoT domain is today a whole ecosystem of different entities and providers where security is a vast component of it. So it really starts with the development of, if you like, the hardware, the design of sensors and chips, taking those into networks. Different types of applications are being developed on top of those devices, and the different firmwares and components that are lying there. There's been different discussions on standards, and I could have put here a slide whereby we make the difference between any different vertical sector that has their own standards and protocols when it comes to IoT. And all of these are just evolving as we speak. For enterprise, there still is sometimes a bit of a requirement to do integration with the existing IT systems. But the whole promise of IoT is really to have it seamlessly integrated. When we take another perspective into an ecosystem, then we see that really one has to follow the other, and one cannot really be working without the other. And that's also the way that we've seen the market developing over the last decade, I would even say, where you have specialized entities working on either data acquisition, data analysis, and then using that gathered data more towards business applications. While on the other hand, the device components are being developed more and more also, for instance, here in Europe, but components are specifically engineered with microcontrollers and communication assets coming from other parts of the world. According to our security experts, IoT has to be really a concern, and it's concern not only for those people who have been implementing IoT as such, but also and mainly for security experts. So McKinsey has done a survey, and we have done similar types of studies, but already in 2017, where IoT, for many of the cybersecurity experts in this case, mentioned that IoT for them was on a top priority. I'd say today that's again the case, even under the circumstances of COVID, while we see that many of the factories are now being trying to be equipped with IoT sensors in order to be able to be resilient for next outbreak of a virus, where they can continue their activities throughout the whole value chain. And if we take then a couple of examples, then we see that security really is a challenge in more than one specific domain. It's a challenge for medical devices, for instance, here, where there's specific requirements, of course, when those devices have to be integrated on personal health. So that goes far beyond the challenges in relation to just purely industry. On the other hand, IoT also opens up quite a number of opportunities. Like, for instance, in the industry, we operate platforms which are called industrial data spaces, where we connect many different industry environments and try to bring together the world of different manufacturing companies and their relations to their peers, where they can share some of the technologies that they have been developing and share also some of the data that they have derived from those technologies. So within the IoT domain, we see an evolution happening, sensors, actuators being the first ones, and then developing those into an operational environment. Usually they are being connected directly into the cloud, which of course causes some concerns towards the people working in security. And if we consider industrial IoT being added into an industrial environment, then it really is a challenge towards security people that have been traditionally working on, for instance, Purdue model, so the IEC 62443, where segmentation is really the baseline, and where we see that today IoT sensors are being put all over the place, connecting to the cloud, connecting across those borders, and actually broadcasting data in many different environments. So we as LSEC, we try to put some clarity in those domains, and we also provide some insights in how we see that the market develops. And we are working today, as we speak, really on some innovation specifically related to IoT and IoT developments on security challenges. So more about those later on. But LSEC today is what we call a digital security catalyst. We bring together the experts from the security industry, like today Trend Micro, with the end consumers, for instance, vertical sectors like manufacturing industries. And we try to work together with them in overcoming some of the challenges that we see happening, for instance, in the domain of IoT. But we have, for instance, this platform called Factory Sense, where we bring those IoT devices, in the case of this VersaSense sensors, and we put them in, we install them physically inside of those factories. And then that's where we come up also with challenges, for instance, related to robots and robot security. and where we are investigating the challenge, for instance, of those robots being connected to the internet, which is happening more and more. So with this, I'd say let's move on to our guest speaker of today, which is Udo Schneider, dialing in from somewhere the south of Germany. Udo, good morning. Hope you're doing well.
Good morning. Yeah, short night, but doing well.
All right, excellent. So we invited you over here to discuss a little bit on the perspectives of Trend Micro on IoT security. And I see that you're also still working from home, which fits perfectly within the red line, if I can say it this way, of our webinar series. So I'm handing over the floor to you to indulge us with your views on IoT and cybersecurity.
Perfect. Thank you very much. Let me just share my screen. Here we go. Share. Okay, and now I should be able to see the nice Japanese themed start screen.
Yes, excellent. You are. We call into the summertime, but it's good to see that you're still in cherry blossom time.
Yeah. You know that's the Japanese theme that Trend Micro tries to aim for. So first of all, let me just thank you very much for the introduction. I tried to do, or let me put it that way. I'm kind of a, let's say, black sheep within Trend Micro, not as a person in general, but because I'm focusing on IoT in general. And the views that I sometimes, let's say, bring to customers that I have in presentations, keynotes, is in many cases a bit different than what you would expect, let's say, from a traditional product-based or sales pitch approach. So just be warned that my, let's say, my view on IoT security is a bit more holistic than just the, let's say, products or solutions that Trend Micro is selling. And it's also, to be honest, let's say our marketing doesn't really like me in many cases because I tend to focus on procedures and things that you can do without having to install something or to buy something, but it's more like how to address IoT security in general. So without further ado, let me just start with why I kind of like and hate IoT security. If you talk about IoT security, it doesn't really matter whether you're talking about industrial IoT or, let's say, consumer IoT space. From my point of view, IoT and IoT security is everything and nothing. What do I mean by that? If you come from a traditional, let's say, IT infrastructure background, for instance, or IT administration background, then you might perceive IoT as just being that small part that's embedded in the, let's say, in the device, whether this is a consumer device, whether this is some kind of, let's say, backpack sensor that's attached to a PLC or to a production line, you just perceive IoT as being the device. And I mean, it's in the name, it's Internet of Things, so thing is in most cases the focus. However, IoT is so much more, and I tend to use an example of fractals because depending on how deep you want to dig, you actually find a lot of complexity, basically as complex as you like, and at the end of the day, you're back to square zero. So if you're talking about IoT, from my point of view, you're not just talking about the actual device, but you're talking about the communications infrastructure, you're talking about the back end, you're talking about data analysis, you're talking about development, which is just a lot of stuff to cover. And the point is, many people, if they talk about industrial, especially about industrial IoT devices today, or IoT in general, or embedded, they still think of those small, low-powered devices. And I mean, those are still out there. Let's say small MCU-based devices, let's say with an Atmel or a chip or something like that as a let's say microcontroller. But to be honest, many IoT devices that are being developed today or are even being deployed today do have a lot of power. I mean, if you take a look at today's reference boards, if you go commercially, you could go for NXP, or you could go for your typical ARM board. If you, let's say, go a bit more low cost, you can take a look at the BeagleBone Black or BeagleBone Pocket, things like that. I'm ignoring Raspberry Pi for a good reason for now, just stick with me. If you take a look at those, let's say, entry-level reference designs today, I mean, they have more power than some servers had 10 years ago. I mean, we're talking about a dual, quad, or octa-core system. We're talking about 2 gigs or 4 gigs of RAM. We're talking about several gigs of mass storage, either on eMMC or inbuilt flash or, God beware, SD cards. So, I mean, we're talking about devices that are actually quite powerful. And the point I want to make here is that the fact that those devices are so powerful kind of leads to a different kind of development approach and a different kind of, let's say, development mentality. And that's where the security problems start in many cases. So if you take a look at, let's say, the whole ecosystem, you can basically, let's say, split up the whole IT ecosystem, let's say, into 3 layers. It's the device itself, it's the communication infrastructure, and it's the backend. And it's quite interesting that regardless whether you're talking about consumer devices or industrial or, let's say, business devices, you can basically apply this kind of differentiation to all the different scenarios. So if you're talking about consumer devices, you might be talking about a fridge that has a browser-based app or a smartphone app that communicates over Wi-Fi to a public cloud service because the fridge vendor just decided to use a public cloud service for hosting his backend. If you're talking about, let's say, industrial IT devices, I've taken, let's say, something like an IVI here that's more car related, like an, let's say, inboard entertainment, but never mind. You might have a built-in touchscreen. You might have, let's say, 4G or 5G connectivity connected to, let's say, virtual private environment for the car manufacturer. And I mean, if you're talking about traditional, let's say, factory-based setups, I mean, a PLC or the robotic arm, I mean, that's still a device. A traditional HMI panel is still a UI device. Same for field bus and field net connectivity. And of course, in this case, the whole SCADA and SES backend would, in most cases, be on-premise, but still the same layer approach applies here as well. So what I want to do with this introduction is to give you, let's say, starting with the actual development process of those devices, to give an insight where and how security matters. Remember, if we're talking about those IoT devices today, we're not talking about a small microcontroller, 8 or 16-bit that's, let's say, programmed in C or in assembler where every bit counts, but we're talking about pretty powerful machines, which also means that the way that many developers or many companies address the development process of those devices changes because they rely on something that they know, and this might not really be something that's adequate. I want to start with something very simple that most of you have seen countless times, a classical 3-tier architecture. I mean, we're talking web here, so we're talking let's say a web shop or a website, whatever. I mean, that's something that everybody knows, that everybody has encountered, that has been best practice for let's say developing web applications in the past. And the funny thing is, if you take a look at this architecture, that's something that most of us would kind of connect to web development or website development. However, and that's where my bad experience starts actually, I've seen more times than I would like to tell actually. I've seen the exact same approach being used for developing IoT systems in general as well. So the thought process, and this is nothing technical, the thought process here is that, well, we have a device here that has a web-based UI or that has a smartphone app communicating over Bluetooth. This device needs to somehow render a UI or provide a UI with data. This device needs to somehow process data, and this device needs to somehow store the data. So this is something that if you're not, let's say, if you don't have a development background, if you don't have an embedded background, which sounds pretty much like a standard web-based 3-tier architecture. So what happens in many cases is that the exact same idea is being applied to development for IoT devices as well. This even goes one step further, that many people, that many, let's say, developers think, well, if I'm going to build a 3-tier web architecture, this also means that I can use the tools and, let's say, development practices that I know from my web experience. So what happens in some cases is that, let me just try to get a pen here. Okay. What happens here is that, for instance, I've seen many IoT projects where the actual development took place in JavaScript. So the front end web application, or the front end GraphQL or REST or whatever interface was done in JavaScript. The application logic itself was done in JavaScript. Due to some resource constraints, some at least, let's say, went for something like SQLite as database, so you didn't have a full-blown Postgres or MariaDB on the device. But still, the way that those, let's say, those devices are being developed as of today in many cases is a traditional kind of software stack. So Node.js or Ruby or Python for the application logic, maybe some JavaScript sprinkled in, or the whole stack in JavaScript. You have the traditional database, things like that, which also means that from a hiring perspective, many IT vendors I've spoken to in the past say, well, we went for the easy route. Why ask to hire somebody who's, let's say, proficient in C++ or C or assembler, maybe a specific assembler for a specific microcontroller? If we have a powerful hardware platform which is able to run Linux anyway, why not just use the software stack that many developers know, using Python or JavaScript or Java, and run this on the actual device? However, what most people, let's say, simply forget in many cases is that you have to take care of the operating system as well. And I've seen more products than I like where some, let's say, proof of concept development started on a Raspberry Pi. And by the way, if you're doing industrial rollouts with Raspberry Pi, unless you're using the compute module, it's a bad idea, because the Raspberry Pi from the hardware platform was never designed to be used in a, let's say, industrial setting, but different story. So you end up with a, let's say, off-the-shelf Raspberry Pi with an off-the-shelf Raspbian Linux on it, and then the traditional stack that developers are used to. So SQLite with a Node.js development environment, things like that. And don't get me wrong, the stack itself might not be the problem. It's just that the context in which the actual device will be used is totally different if we're talking about IoT. If you're talking about a web application, it's pretty easy. If you, let's say, find a bug, or if you have a vulnerability in your code, to simply push a new version and deploy the new version on Kubernetes or Docker, or let's say the actual platform of your choice. If you have the same software stack, including your application, on 20,000, let's say, devices somewhere on this blue planet, then it's pretty hard to just quickly update the stack. So on the first hand, you have, let's say, developers which have, in many cases, no embedded experience because they don't need it, because they use their well-known stack. And on the other hand, the problems start only later on, once you realize that you actually, that the embedded device, although the actual program is kind of similar to a web stack, the actual context requires totally different thinking. And I just want to show you some things where actually just applying a traditional web-based approach to, let's say, embedded development can lead to some huge problems. The first one is pretty simple, and that's dependency hell. If you're developing, let's say, your firmware, I mean, you have your operating system, you have your packages, like let's say a web server, like a database, things like that. You have your programming environment, let's say JavaScript and Node.js, and on top of that, you have your own packages. So if you take a look at this, then up here, that's maybe your own package. However, for instance, your own package has dependencies, let's say, to an XML parser in JavaScript, for instance. your package has a dependency, let's say, to an HTTP daemon. This HTTP daemon is a package that requires a specific, let's say, Linux kernel, and so on and so forth. This XML package that you actually imported has another internal dependency, let's say, for a strings package, and so on and so forth. So you're basically ending up with a whole dependency tree that your application is dependent upon. I've taken the liberty of kind of stealing a picture from a Node website. These are the most important Node.js packages and the dependencies among each other. So what you basically end up with is you are dependent on a whole lot of different third-party dependencies. And the important part here is, if we're talking about those dependencies, yes, this is not a package that you're responsible for, but that's a package that if there is a vulnerability within that package, let's say within a specific Linux kernel or your Raspbian Linux or a specific package or a package dependency, it's basically your problem, because if this dependency through this dependency chains means that your package, your product is being vulnerable, your customers won't care whether this is a vulnerability somewhere down the line in a Linux module or in a JavaScript module. Your customers care about, well, your product has a vulnerability, go and fix it. So this is something that I would like for you to keep in mind. And there are several things that you can do, let's say, to actually approach this kind of, let's say, I call it dependency hell. There are tools out there. I've used one that's pretty prominent, let's say, in the open source space, Sneak or Snick, however to pronounce it. That's basically something that you would integrate into, let's say, your source code, something that you would integrate into your CI/CD pipeline, which would, first of all, scan your code for, let's say, obvious vulnerabilities, as well as tracking dependencies. So from your point of view, you would have to keep track of which kind of firmware do I have deployed on which number of devices, and using something like Sneak or another tool I'm going to show you in a second to kind of verify, is there any vulnerability that has, let's say, become known after the firmware has been released that I need to take any kind of action for. So Sneak would tell you, well, for instance, within your firmware that you deployed half a year ago, there is now a vulnerability in an XML parsing library. You might also encounter the concept of so-called BOMs, bill of materials, something that's pretty common, let's say, in the manufacturing producing industry, and somebody kind of let's say enhance this concept to so-called SBOMs, so software bumps. Basically, the idea is like with a physical machine, you're keeping a bill of materials. Which parts, which components are part of your product, and if one of those components, let's say, has a faulty temperature range, things like that, then you might check according, let's say, to build number and batch number, serial number, whether or how many of your products are being affected. Same idea for software bombs. So basically, you're keeping a bill of materials of all the components. I mean, that's the theory, to use all the components that your product is dependent upon, including, let's say, Linux packages or libraries, so binary libraries, programming language libraries, source code, things like that. And once again, I think that's a quote that I got from IDC. Let's say manual is the worst enemy of security. So the basic idea is also to automate everything in this regard. So the moment that you actually create a new firmware, or even better, the moment that somebody pushes a new commit to your repository for, let's say, being built, things like that, this will automatically kick off a run of an SBOM tool. I've used an open source tool here from OWASP, dependency track, just an example. This will automatically kick off, let's say, an SBOM collection process. So all the dependencies regarding your programming packages, binary libraries, applications, modules, things like that, will be put, let's say, into into the database so that later on, if you have, let's say, if a vulnerability becomes known in one of the packages, you can easily go back, say, well, this vulnerability was part of an libxml binary with a specific version number, and I have this this dependency in those 3 versions of my actual firmware. Let's do something about it. So the idea here is once again to get visibility in embedded components, because once again, we are not in a time where somebody does the development, let's say, using C or assembler. We have in many cases new IoT products being developed in, as I said, Python, JavaScript, whatever, including all, let's say, the baggage, or to be more precise, the luggage that they actually carry with them, which includes dependencies. Another thing that's quite important from a, let's say, software standpoint, or security standpoint to be more precise, is to be able to always build, let's say, the firmware or the actual binary from source in a reproducible way. And that's harder than it actually sounds. If you nowadays, for instance, if you take a look, take a simple C program, include standard IO, main, printf, hello world, the standard C or C++ hello world program. If you nowadays compile this C code 2 times, let's say, on the same machine with, I don't know, let's say 5-minute difference, you might end up with 2 different binaries. So the actual hash of the binary would be different. Why is that? Because C compilers nowadays, in many cases, for instance, include things like compilation information within the binary. And this compilation information might include something like the time of day that this actual module was being compiled. So because the timestamp differs in the 2 binaries, so does the hash. Another security functionality that kind of makes life hard here is that C compilers start, let's say, to load binaries at different entry addresses, or especially if you're talking about shared libraries. Even if you compile the same code twice, the actual entry points or the function addresses within the library might be different. This, the idea here is to, if a, let's say, attacker gains access to, let's say, your web server or a buffer overflow, whatever, that it's quite hard to predict an actual entry point because it has a fixed address due to the fact that it has a randomized address. However, this makes things like reproducing builds quite hard. You can go all the way of, let's say, digitally signing commits, of digitally signing releases, but if somebody asks you, well, could you prove to me right now that the source code that you had, I don't know, 10 days ago is the one that you used to build the very exact same binary? And in many cases, you can't, due to those problems. That's one note that I want to give you here. There is a project, I think this originated from Debian originally, Reproducible builds, which aims at building a, let's say, a build environment, so virtual machines, including C compilers, things like that, which allow you to omit those problems. So the idea is that if you put in the same source code into this build environment twice in a row, you will get the exact same binary identical output. This might be especially interesting if you're talking, let's say, if you're working with critical infrastructures where you actually might have to prove that a specific build that you had, that you created, I don't know, 10 days, 10 weeks, 10 months ago, is the same that you would actually produce right now. So that there is a direct one-to-one match between the binary and the source code that's supposed to build that binary. Another thing that we encountered quite often right now, and that's something that blew my mind at first, is running Docker on embedded devices. And my initial thought was, why would somebody want to run a Docker daemon on an embedded device? First of all, because the devices are, to be honest, quite powerful enough to do so at the moment. And the idea was pretty simple. The idea here was that if you have a let's say, somehow embedded device or an IoT device, if you want to add functionality, I mean, many vendors nowadays want to, let's say, provide their own app store to either, let's say, provide additional functionalities or for third parties to sell additional functionalities through their devices. And the basic idea here was to first of all, separate different critical components on the same machine. So I've taken a simple example here of a production line or a robotic arm. So you might have one container running the actual, let's say, UI endpoint. So this may be a GraphQL or a web interface or whatever. You have a separate container which does, let's say, the actual control or inverse kinematics, things like that, actually handling the robotic arm. You might have, once again, another container which provides external interfaces like, I don't know, for Java or for, once again, GraphQL, REST, JSON, whatever. And the idea here is pretty simple. You have, let's say, either everything is running on ARM, which is the majority of the cases nowadays, or you have something like, let's say, something more powerful like an x86 platform with an additional, let's say ARM or Untitled-based, let's say daughter board for the actual I/O. So if you have some very time-critical functions or safety-critical functions, that's also quite interesting. Those are being implemented, let's say, on the same machine, but let's say not within a container, but on the actual bare metal, and everything else is running on top of the Docker daemon as a pluggable functionality. From a maintenance standpoint of view, this is quite interesting because you could easily separate different components. You can set limits. You can control how the different containers are interacting with each other. That's something that Docker provides, let's say, out of the box. But you could also, and that's the point that actually then made sense for me when talking to this customer. If you want to provide, let's say, your own app store, then you have to think about, first of all, what's the distribution format for that app store? And second, you have to think about, how do I provide any unwanted interaction between the core components running on the embedded system and, let's say, third-party components running on the same system? Think of something like a small protocol converter. You have a simple, let's say, small box somewhere in your cabinet, which just provides functionality, let's say, to convert from Profinet to OPC, or from OPC to Modbus, Modbus to S7COM, things like that. And a customer requires something special. So he not only requires something from OPC to S7COM, but he wants to tinker with the actual data. That's something that you as a vendor might not be able or not be wanting to provide. But if you have a third-party vendor that says, well, we can provide that, then this third-party vendor could provide, let's say, that functionality packaged as a Docker container. Once again, security is being enforced through Docker rules. The packaging format, let's say, is defined because let's say the plug-in format is the actual Docker container, which makes sense from a maintenance point of view, which makes sense from a security point of view, which, however, means out of the sudden you are running a Docker container or a Docker daemon on the embedded device, and you have to run, let's say, your own container registry as well, because that's basically your app store. So once again, due to the fact that those devices are much more powerful nowadays, you tend to have new possibilities, including new risks. And from a, let's say, from a business perspective, this makes perfect sense unless you forget security. And that's the point where I normally start with a discussion, because yes, it might make sense in certain scenarios to do this with Docker, but please then always also take care of security. So which brings me to the next point. If you're talking about Docker, you might not want to publish, let's say, your critical package on a public Docker infrastructure or public Docker registry, which basically means that you have to run your own Docker registry, including all attached dependencies and requirements. So once again, yes, we started talking about an IoT device, but out of the sudden, we're talking about running a Docker registry. And we're not into, let's say, traditional data center or workload security. We're still within IoT security. I hope that's something where you can actually, let's say, get my initial statement that yes, IoT security seems to be simple on the surface if you take a look at the device itself. But if you start to dig deeper, you might find any or every IT or IT security related control in there as well. Last but not least, if we're talking about cryptography, and that's something that many people, let's say, basically don't think about. However, when talking about IoT, you have to think about crypto in general, because you want to make sure that you have some kind of trust anchor or certificate in your devices. The best would be tamper-proof, so you have to make it in hardware, because, let's say, reliable crypto in software where the device is under full control of a potential attacker doesn't make any kind of sense. So we're talking about a trust anchor either within the SoC, or let's say with an additional HSM added to the SoC, or maybe using let's say an additional hardware device, let's say attached over SPI or IC2 square, things like that. Why is that so important? Well, first of all, you want to make sure, especially if you're in an industrial context, you want to make sure that the device only runs, let's say, certified and approved firmware. So we're talking about ensuring that the boot sequence is correct, so classical secure boot approaches. We're talking about verifying, and that's what the, let's say, secure boot normally does, verifying that the firmware that has been, let's say, added to the machine or being upgraded, that it's actually a valid firmware, that it has not been tampered with. We had some cases where some vendors actually verified the firmware on download. So the firmware was downloaded, was verified during the actual download process, and then the firmware was written. In this case, from my point of view, dumb idea, but different story, was written to an SD card. However, once it has been written to the SD card, the boot loader didn't verify the firmware on the SD card. So it was pretty easy, let's say, to get the official firmware, have it written down to the SD card, then simply unplug the SD card, change something in the firmware image, plug it in back again, and the device was happily running with a heavily modified firmware. That's something that you definitely don't want to do, especially if you are talking, let's say, about sensitive data being collected or transmitted using that device. And that's, from my point of view, that's the angle that worked best in many cases with customers if they have some kind of license features that are dynamically either enabled or disabled on the device. So you have the same device basically for every customer, but every customer might choose to buy different license or license sets. And if those license sets are not being secured by strong crypto, for instance, then you're basically opening the market, let's say, for, and I won't say cracked firmware, because the firmware is always the same, but cracked licenses. The problem about crypto is you definitely need it, but it's really hard to do it right. And so my advice at that point is, if you're talking about crypto, don't do it. Or to be more specific, don't do it on your own. It's so easy to get crypto wrong, to do a silly mistake when implementing crypto that kind of breaks your complete chain. So if you are using crypto, and by the way, you should, do not try to roll your own. Do not try to tinker around in cryptographic protocols. And with protocols, I mean not only low-level protocols like, let's say, RINDAL or AES, DES, RSA, things like that. I mean, with protocols, the whole, let's say, cryptographic applications. So verifying a binary or signing a, let's say, a payload. That's something that, from a development point of view, you should have a library which allows you to say, I have this piece of data, this blob of data, I have a certificate, please sign this firmware with this certificate. Don't start with, let's say, plugging crypto algorithms together on your own, because, as I said, it's so easy to do something wrong. There is a pretty famous example how easy it is, for instance, to get crypto wrong, where somebody used AES 256 in the firmware. However, he used the wrong mode. So he was using ECB. So basically using the same crypto key for every, let's say, for every, let's say, size or every chunk of data. So yes, the data itself was encrypted, but the whole, for instance, if you encrypt an image, then every 16 bytes were encrypted with the same key. So if the image is large enough, you can easily visually detect the content, even though it was encrypted. So that's something, if you talk about, let's say, development, if you talk about crypto, let's say crypto in development, my advice, don't do it. Use existing libraries or use existing procedures. That's the development process. You see, I spent a lot of time on the actual development processes. The remaining part will be quite shorter because from my experience, it's quite hard to, let's say, attach security to IoT devices once they have been deployed. I mean, that's something that you are quite used to if you're talking, let's say, about endpoint security or infrastructure security. I mean, most of the IT security industry deals with bolting on security controls after the actual, let's say, let's call it victim has been deployed. And that doesn't really work for IoT or industrial IoT devices. You have to get security right from the beginning. And from my point of view, that's during the development process. Otherwise, it makes things very, very, very hard. That's why I spend so much time on the actual development process, which, by the way, also makes me the kind of black sheep within Trend Micro, because it's not so easy as just selling a product, but never mind. Still, there are a few things to consider if you're talking, let's say, about the following life cycle or lifetime in general. So I would like to also split up the lifetime once again into those three layers, like actual device, communications, and the back end. One thing that also was quite interesting when I encountered this the first time, and that's all from a security perspective, is the importance of telemetry, or let's say log data, or let's say data lakes, or event logging, whatever. I call it telemetry in general. This does include things like, let's say, the old kids on the block, like New Relic, for instance, which originated in the traditional web stack, but it's also usable for IoT devices. The new kids on the block would be using Grafana as a back end, or InfluxDB. The basic idea here is that even though those, let's say, those telemetry data points are not security information per se, they still help to detect and let's say somehow follow security related issues. Let me give you one example that actually opened my mind with a customer. We had a customer and they were deploying CCTV cameras. So those classical Wi-Fi or Ethernet based CCTV cameras that you see all around. And those cameras have been infected in a big way, to make a long story short. The interesting thing was that the infection on those cameras was not detected by a security control. The infection of those cameras was detected through standard telemetry, because they were getting constant information from the cameras, like CPU load, memory usage, things like that. And the only hint that something was wrong was that suddenly a lot of cameras had a very, very high CPU load. So this has nothing to do with security in the first place, but this was something that actually triggered their interest. They said, well, why does the camera have such a high CPU load? And then they started investigating. And of course, then they also found that those cameras have been infected, and that crypto mine was running on those cameras. But still, the initial data point was not security. The initial data point was resource consumptions. Same for network communications or network communication behavior. How much data does a device transfer? What's the interval between different communication attempts, things like that? What are possible communication destinations? I mean, these are all things that can be easily monitored using traditional telemetry data, or let's say a SIEM system, or even a log database, but which provides valuable information from a security point of view. So the first point I want to make, if you're talking about, let's say, the actual lifetime of, let's say, securing a system while it's running, not during the development phase, is to make a long story short, from my point of view, log as much as you can and as much as is allowed. That's a different story. But those data points might help you to find out about security-related issues. Same thing for those bill of materials. You remember during the build process, we built a bill of material, a software bill of material for each and every firmware. So we know pretty well which library is part of which firmware. And I have to admit, most solutions do this automatically. But once a vulnerability becomes known in a library or in a package, you can easily verify whether this vulnerable library is a part of your firmware, and if it is, if it matches the version, so if the actual firmware is vulnerable. If you combine this with, let's say, a broader monitoring, like also monitoring how many of your devices have been upgraded to which, let's say, which version of the firmware, things like that, you can easily determine how critical this vulnerability is. So you could say, well, that there is a vulnerability in libxml. Do I have an affected firmware that's affected by this libxml vulnerability? Yes, I have. That's firmware 4711. Okay. How many devices do still or do already run this specific firmware? Okay. If it's just 2 devices, maybe that's not that big an issue. Yes, you have to update the firmware. Yes, you have to patch them. Yes, you may have to tell the customer, dear Mr. Customer, please update your system. But the actual, let's say, measures taken are much lower than if you find out, well, this firmware 4711 is deployed on 10,000 devices. So this gives you, once again, let's say from a reaction or risk management perspective, gives you some background, whether you want to recall the devices physically, which is, by the way, always a bad idea, at least from a business point of view, whether you can simply and maybe silently, I mean, that's not what I would prefer to do, but still many companies say, well, let's just keep this under the hood. Yes, let's document it on the website, but let's just not tell everybody, at least not loudly. You can simply release a new firmware and wait until the majority of the devices has grabbed that firmware, hopefully automatically. You could deploy a virtual patch, which maybe just closes the actual, which makes it impossible to exploit the vulnerability without actually patching the firmware. Once again, one possibility to do that, for instance, would be if you have that's something that I've seen in production, if you have a Docker container on your device, which does the whole network communication, so everything that's entering or leaving this device is going through the Docker container, then you could only upgrade that Docker container, basically denying network access to the vulnerability, and wait until the next full-blown patch cycle until the complete firmware is being upgraded, just as food for thought. So this is something that's quite interesting, and it's always, once again, it's more about monitoring than about, let's say, enforcing. If we're talking about upgrading, you might have to think, or you will have to think in many cases about upgrading the device in place. So firmware over the air is one of the new buzzwords out there, and this implies a lot of things to be in place. It's pretty easy to let's say to implement firmware over the air. However, to make sure that everything works after the firmware has been transferred to the device, that's quite hard, because that kind of implies once again, coming back to one of the initial points, requires a trust chain within the device. Am I able to verify that the firmware I just got over 5G or Wi-Fi, whatever, that this firmware is a legitimate firmware, yes or no? And can I also verify that the firmware that's on the device itself, maybe let's say on the second or first boot partition, is the correct firmware? So there are a lot of things that have simply to be, let's say, to be in place for something as, at least from an, let's say, a non-technical point of view, something simple as firmware update to be secure. And the interesting thing is, when we got into projects regarding, let's say, firmware over the air, this was mostly in automotive, by the way, then the main questions were, well, how do we make sure that the firmware is being rolled out to all the devices? How can we make sure that the bandwidth is enough? How can we make sure, or how can we ensure that a specific percentage of devices is being updated within the first, I don't know, 2, 3, 4, 5, 6 hours, days, weeks. And I mean, those are primarily infrastructure questions. However, when we started to dig deeper, say, well, how do you actually verify that the firmware is correct? What's your trust anchor on your IVI? Then we basically, let's say, opened a can of worms where it became obvious that those, from our point of view, requirements that had to be in place before actually thinking about a secure firmware over the air update were not in place. So that brings me back to, yes, firmware over the air, that's a lifetime topic, but still it requires a lot of things that need to be in place before, and those things, once again, are part of the development. If we talk about another topic in the, let's say, communication department, then we're talking about 5G, or let's say in general communications. It's quite interesting that many still perceive 5G as just being the faster radio. To be honest, there is nothing more, let's say, uninteresting about 5G than the actual radio. However, 5G is a new way to design networks. So we have technologies like software-defined network, which basically rewrites the whole way that you route data. And we also talked about technologies like network function virtualization, where all the lessons that we learned in data center virtualization were basically applied to network functions. It's also quite interesting that if you're talking about, let's say, about closed networks or campus networks, that many providers nowadays would even allow you to offload some of the functionality that you had to do on-premise up to now into the backbone. So basically, you can in some ways configure the backbone that you rented from the provider to do your bidding. That's something that's a big thing within 5G. In addition to things like low latency, bandwidth, things like that. However, from a security perspective, those two functionalities are the things that you can actually control in many cases, which would allow you to even provide security to your IoT devices, let's say, from the infrastructure, from the communications layer. And last but not least, and I think that's the shortest part of all, is the actual back end. And I think I just have one slide on the back end, because if you're talking about securing the back end, I mean, that's traditional data center security. That's workload security. So we're talking about things like, let's say, running systems in a, let's say, in a predictable fashion. We're talking about things like DevOps, definitely. We're talking about, I mean, that's just modern software deployment or development. We're talking about, if possible, do everything within your source code repository. Don't do any kind of manual tasks anymore. Automate everything, including security, to achieve higher, let's say, higher, a higher, let's say, a better maintenance and a higher and faster rate of software updates. But once again, yes, that's part of IoT in general, because no IoT device exists in vacuum. They don't exist in thin air. They always have some kind of backend they talk to. But the backend, I mean, that's traditional software development. I do see a question here. Just give me a second. Okay, it's regarding security monitoring. If we talk about security monitoring, and I hope I do get your question right. The best. Sorry.
Yeah, I was going to say we can address it also later on, but go ahead if you like. No problem.
Okay, it's just a short one. If you let's say the best would be if you could build in monitoring telemetry systems into the actual device itself. However, most vendors would not allow you to add anything, let's say, later on to your device. There are still other monitoring solutions that can be either attached to the device, or where you could simply, let's say, for instance, monitor a switch or a router, or just take a look at the net flows and try to, let's say, get information about network communication, things like that, without affecting the device. As I said, it would be better to do it in device, but if you don't have the chance, if the device is already there, just let's say, get what you can have access to. And that's in most cases, that's really network monitoring. Something that many, especially developers not familiar with embedded devices, forget is how to, let's say, to think about decommissioning a device. We always think about developing it, we always think about how to deploy it, but we don't think about the time or the date when the device goes out of service. And it should go out of service in a controlled fashion. That's especially interesting or especially important if you're talking, once again, about licenses or features that have been enabled on the device. So you don't want somebody reselling licenses from, let's say, from your old or decommissioned devices on eBay, for instance. If those devices have any kind of, let's say, critical or important data, like recipes, like control data in general, you want to make sure that this data remains on the device and it's not possible to actually, let's say, pull it off the device without appropriate measures. And that's maybe not as interesting for industrial context. If you have any kind of, let's say, PI information on the device, GDPR might be an issue. You don't want, if you have personal data on the device, you want that device popping up on eBay and some journalist finding that the old device that has been that he bought on eBay still has PI on it or accessible PI on it. So, long story short, how does this Trend Micro fit into that overall picture? And that's now the marketing part, more or less. First of all, if we talk about Trend Micro, one of my colleagues, Dimitri, I think something like a month and a half ago, did already a WebEx on Trend Micro's industrial solutions. So we can basically cover all the different, let's say, layers in, I think that's according to Purdue. So we do have solutions in all those layers. We also have solutions, and that's something that's not so well known. Come on, give me. We also have solutions that can be integrated into the actual devices. So we're not talking about development yet, we're talking about deployment. So if you're talking IoT gateways, an IoT gateway vendor could build in Trend Micro functionality into his IoT gateway, but that's still very, very product focused. So if we talk about development, and I won't give you the exact product names, we can provide solutions to actually, let's say, provide a source code as well as runtime protection. So we do solutions like providing, let's say, resource and security telemetry. We provide functionalities to actually, let's say, do in the app during runtime and once again development to check security. We can help you with securing your Docker registry or your container registry, including those images. So that's something where we can plug in. If we're talking about the device itself, to make a long story short, you can get all the Trend Micro technologies as an SDK for you to pick and choose for your device. So if you're doing device development, if you don't want to, let's say, invent your own application isolation or your own IDS IPS, we can help you with that. If we talk about communications, anything regarding VNF, we can talk about. So Trend Micro has its own VNF instance with an IoT focus that allows you, for instance, to provide security from the backbone. We provide, let's say, customized SIM or eSIM cards for your radio-enabled devices, where, for instance, the SIM card would provide security functionalities to make sure that the communication is authenticated, is authorized, that the configuration is correct and things like that. Traditionally, Trend, of course, we do the whole back-end security stuff as well. I mean, that's where we do a majority of our business right now, regardless where you're running on bare metal or on virtualization, cloud, whatever. So basically, and I didn't put any product names here by intention. So basically, if we talk about Trend Micro let's say, from an IT perspective, we can help you with the complete stack. It's just that in many cases, and that's one warning, in many cases, those solutions might not be something that you find on our official price list or website, whatever. I would say everything regarding communications and backend is something that's a pre-packaged product. This is something that you might find on the website. Most of the things that are, let's say, on the device itself or that are for the development process is something that has to be integrated. That's not as obvious a product as many others. So if you have any question regarding this one, just grab me later on. So to wrap it up, and I hope you get my idea here is IoT security can be very simple if you just concentrate on the device, but I think that's not what IT security should be. IT security should take a look at the whole system, and that makes it very, I don't want to say complex, but it's just a lot of moving parts that you have to take care of, including development. And that's something I can't stress this one enough. Coming from an IT security infrastructure background, we tend to think of bolting on security afterwards. However, this doesn't really work for IoT security. So if possible, try to be in the process as early as possible, and this includes development with all the requirements, with all the dependencies, and with all the efforts. Take a look at relevant standards. I think you already mentioned IEC 62443. It's one of my favorites. I have to admit, it reads the read is even more boring than ISO 27K, but hey, it's the standard. It's the standard. Think about your tool sets, especially if you're talking about development. You can pick and choose different, let's say, tools for all your different needs, like, let's say, building your bill of materials, like running your Docker registry, like putting in telemetry, things like that. Or, and that's a shameless pun, no, I'm not getting paid for that, but you should definitely take a look at GitLab. GitLab is much more than just a source code repository, but has many of those security functionalities also built into the platform. So it may not be as nice as, let's say, your handcrafted best of breed solution, but it may be a better start if you don't have the actual experience. Last but not least, one paper that I found quite interesting, especially for non-IT people to read, to understand the complexity of IT and all the different bits and pieces that you have to, let's say, keep in mind, is a paper from IEC, from the IEC, I think it's Institute, IoT 2020, Smart and Secure IT Platform, highly recommended. And very last slide promised, if you have any questions regarding this one, regarding protecting IoT, protecting development environment, things like that, always feel free to contact me. The worst thing that can happen is that I will just, let's say, forward you on CC to a colleague of mine if it's not my actual topic. And with that, I want to conclude the slides and hope that you at least found some interesting bits and pieces that might be worth thinking about.
Absolutely, Udo. And I think I'm definitely now speaking for all of the participants and listeners and viewers later on as well. So thanks for this quite substantiated perspective on IoT security. You've taken a really 360-degree overview. There's been quite a number of interesting things that you started mentioning. I think you, besides me, we're probably the only ones in Europe trying to advocate the use of SBOMs, software bill of materials. I also find it very sensible to consider. You also take it a step forward using the perspective towards Docker. So let me ask you two things about this, and then we'll have to wrap it up because we're seriously running over time. But in terms of the software bill of materials, have you found basically already any IoT provider or even enterprise which has been building these things? I know there's some out there, specifically in the healthcare space, but what's your perspective?
To make a long story short, I did not yet find, let's say, an IoT vendor doing this. Although I would personally, I do not understand why, but that's a different story. We did already find a few, let's say, enterprise or let's say in-house development teams within enterprises who are using software bills of materials to be able to track their builds for, let's say, especially for let's say ERP or SCM related apps. So that's definitely. Still, the majority of the software bumps that I encountered also in Europe, interestingly enough, was in healthcare. And the information that I got was that if you want to provide, let's say, devices or services to US government institutions, then one of the requirements that comes up quite often right now are those software bills of materials. So it's not that it's being done because people see the point in it, which I think it's a pity, but because it's being requirement by many US institutions as of today. That's the main driver that I heard of.
Yeah, I tend to agree. I think it's something that is really being increased by the amount of at least large sector federations, and indeed healthcare being one of them. But I think it's becoming much more, if we can implement it, a way of showing good practice, and especially also from the perspective of cybersecurity, with the complexity of IoT and many other devices as well. We've started to instrument this for robotic security. I think it makes a lot of sense, even from the perspective of the cybersecurity world, to go towards a cybersecurity bill of materials, so a CS bomb.
Yep.
That's in correlation with the reference integrity manifest. I think are two major components, as the way that we see it in any case for future cybersecurity point of view. Another one, bit related. How many IoT devices have you discovered using Docker? Because I think that's definitely up and coming. Those devices which have, of course, the power and the capacity, because they need to be, of course, operated through a little bit more than just a single cell battery or just a solar power or induction. So the type of device that you need there is type 4, maybe even type 5 in your IoT list. How many devices have you discovered up to now that have contained Docker functionality? And I think in that perspective, I think it would be useful to consider the use of things like security within, let's say, a Docker environment that then can look into and do the inspections on the lower levels as well.
Yeah. To make a long story short, in production, zero. So I'm not aware of any product that we've been involved with that runs Docker in production right now on IoT devices. I'm trying to, let's say, countermat. I would say, depending on how you count, I was involved in 4 or 5 projects where they actually do. It's not a POC stage. It's much further than POC stage, where they actually, let's say, use Docker or are willing. They want to use Docker for the next generation of IoT products. So it's not deployed yet, but it's definitely coming. And the main argument was definitely to have, let's say, a package format for, let's call it, for plugins or for third-party apps. This was the main argument, because you don't need to reinvent the wheel on your own for, let's say, packaging and plugins and verification, things like that. You can simply, let's say, use the existing infrastructure for Docker. So to make a long story short, in production, 0. In very, very late stages of development, or let's say beta testing, 4, depends how you count, maybe 5.
Right, excellent. Final question, and basically also putting some things out to you. We are working with a couple of startup technology companies here in Belgium as well. One of them focusing specifically on firmware security, called Firmalizer. I think that's definitely something also for you to discover and maybe to integrate with the offerings. But in relation to this, I'd say one of the challenges that we see is really to get a good perspective on the vulnerability assessment of the IoT devices. You mentioned that you're using SNCC. Is SNCC sufficient for you in terms of providing its overview?
To make a long story short, we're not using SNCC. I was just mentioning SNCC because it's one of the, let's say, most well-known open source offerings out there. We do have an integration with SNCC as Trend Micro, and we also do have our own scanning solution for this. And from my point of view, that's simply an easy win, like with software bombs. I mean, if you integrate this into your CI/CD pipeline, it basically costs you nothing and provides you a list let's say, of I don't want to say configuration, but it provides you a list of dependencies which you can check later on. And that's something that I don't understand. I mean, that's coming from an IT infrastructure background. If you're taking a look at ISO 27K, everybody always asks you to check the state of all components, including software patches and things like that. And you have to do it manually in most cases, or using a patch management solution. Whereas if you plug this into an IoT development process, you're getting more or less for free. You just have to act on it later on. And that's why I don't understand why why so little companies are actually doing it.
Yeah, okay. All right, Udo, I'd say thanks again for providing us this good overview and a very insightful webinar that we can add to our series. So thanks a lot for this. Thanks for joining in this early in the morning on a Tuesday. I hope you will get some rest now after a couple of nights, a couple of hours only of sleep. I wish you a very nice summer holiday. And I'm definitely hoping to see you in the very near future, also live in any of our face-to-face events. In any case, as well. So thanks for this. Thanks also to Trend Micro for facilitating, and stay safe, stay secure in the next coming months.
Thank you very much, and thanks for having me. Take care.
Bye.
Bye.